implemented over Bluetooth. It uses a Bluetooth dongle to attach to the OBD port inside of a vehicle that interfaces with the diagnostic computer in the engine to get data and transmits that to a Raspberry Pi unit. The Raspberry Pi processes the raw data, converts it into numbers, and then formats the numbers so that they can be displayed on the screen. The screen we're using is a transparent OLED display from 4D Systems. We went with a transparent display so that it wouldn't interfere with the rider's field of vision. It's mounted to the helmet using a 3D printed armature, and it's powered by a battery pack. The battery pack lasts approximately 2.5 hours, which should suffice for a long commute both ways. And, the system is meant to be an attachment to an existing helmet as opposed to some of its competitors, which are standalone units, which is what allows us to bring the cost down so much. This approach allows a user to just go out, buy it, stick it onto their own helmet. Instead, it also allows them to move it from helmet to helmet as they desire. The main program is written in Python, and it handles the communication fairly well. There is approximately about a 1.5 to 2 second latency, which we are looking to improve with further iterations. The breakdown of the work, Thomas and Yushan jointly developed the power solution for our project. I, along with Yifan, developed the software, and Qpon was in charge of modeling the 3D printed armature. We have a working prototype connecting to an emulator that mimics the responses of a vehicle diagnostic computer. So if you would like to see this thing in action, you can visit our table at the poster section. I'd like to now open the floor for questions. Yes?
Where does the Arduino go? Is it on the helmet or?
That's a Raspberry Pi, and it mounts to the back of the helmet. We went with the Raspberry Pi just out of familiarity with the system. Yes?
Why use a battery pack instead of wiring it into the electrical system on the bike?
Well, it's for ease of use, so you just approach the bike, power it on, it connects automatically, and then you just drive off. When you're done, you step off the bike, take off your helmet, and you're on your way. There's no fussing with the plugs or anything like that, aside from the initial installation of the Bluetooth dongle.
What kind of effort did you need to go through to design the screen? What would display on the screen? How transparent it was, etc.
The manufacturer of the screen provides a API for programming their devices. So it was just a matter of setting it up to receive serial communication from the Raspberry Pi, and then it's up to the screen's display driver to convert those numbers and then draw the details. The way we have it set up, it doesn't, it draws bars, and it essentially mimics a 7-segment display with bars, and it's up to the screen entirely to figure out what bar to draw at what time based on input from the Raspberry Pi. The transparency does cause contrast issues when you're in a bright environment. We try to address that by modulating the brightness based on a photo detector, but that proved to be ineffective as the model of screen we're using presently in this prototype is not sufficiently bright to make that big of a difference with the active modulation.
Any more questions?
Yes.
Were there any regulations you had to take into consideration since this would go on a motorcycle helmet?
We did some research into laws regarding external